Welcome to the Explainer. Sometimes the biggest mysteries are hiding in plain sight. Today, we're going to tackle one that's hidden in a word you probably use every single day without even thinking about it. All right, let's dive right in. Section 1, the everyday enigma. And it really does all start with what seems like a super simple question.
So, how many is many? Seriously, think about it. Is it 3, 10, maybe a billion? The crazy thing is, there's no single answer. There's no number you can just point to.
And right there, that's our whole enigma. This simple, everyday word, it totally breaks the fundamental rules of formal logic. It just throws a wrench in the works for any system that needs things to be black and white. So, let's get into it.
Okay, Section 2, when logic fails. And this is where things get really interesting. See, the problem pops up the second you try to treat the word many like it's some precise mathematical term. Spoilers, it's not. It plays by a totally different set of rules.
Just look at this. It nails the first huge problem. Many is all about context. If you're talking about a class of 10 students, many might mean, 4 or 5? But if you're talking about the stars in our galaxy, well, many suddenly means billions. The word itself has no fixed number attached to it. Its meaning is literally created on the fly by the situation.
For formal logic to work, it needs rock-solid rules. One of the biggest ones is this concept called isomorphism invariance. I know it's a mouthful, but the idea is actually pretty simple. It just means that a logical word, like all or some, should only care about the quantity of things, not what the things actually are. All apples or all planets, the logic works the same way. But many? Oh man, it just completely flunks this test, which is our proof that it's just not a purely logical term. So when you put it all together, you get a real logical headache. It's totally context dependent. It lacks that isomorphism invariance we just talked about. It's this weird, ambiguous, intermediate quantifier that's not quite some and not quite all. And its meaning is always shifting based on what we expect. It's a word that just refuses to be pinned down by rigid, classical logic. So what do we do? How do you solve a puzzle like this? Well, if logic can't nail it down, maybe we're just using the wrong tool for the job. So for Section 3, let's look at a different approach, the context clue. What if we just embrace the context instead of fighting it?
This brings us to a framework called dynamic semantics. And this idea kind of flips our whole understanding of meaning on its head. It says that the meaning of a word like many isn't some fixed thing you look up in a dictionary. Nope. It's something we actually negotiate and define during a conversation. The word doesn't have a meaning, we give it one as we go.
And this happens in real time, which is so cool. Our conversations literally sharpen the meaning. You start with something vague, right? Many people attended the meeting. Okay, what does that mean? But then you add context. Oh, it was for a small book club of 10 members, and boom, suddenly the meaning gets sharpened. Many is now clearly understood to mean something like 8 out of 10. The meaning was created right there in the conversation. But wait, there's another really fascinating way to look at this. Section 4 is all about a fuzzy solution. What if the problem isn't the word many at all? What if the problem is our super strict, black and white view of what's true and what's false? And this leads us to something called fuzzy logic. Classical logic, it's binary. A statement is either 100% true or 100% false. That's it. But fuzzy logic, it's different. It says truth can be a matter of degree. A statement can be, say, 70% true, or maybe just 25% true. It's a system built from the ground up to handle the beautiful messiness of human language. Right, so fuzzy logic systems, they formalize these imprecise ideas by letting sentences be true to a degree. So instead of asking, is it true that many people came? Fuzzy logic asks, to what degree is it true? And that changes everything. Think about it. If 5 people show up to that 10-person book club, the statement, many people came, isn't just false. Maybe it's 60% true. It's a way for logic to finally embrace ambiguity, which is why it's so incredibly powerful for things like AI, which has to make sense of our messy human world. Okay, so we've gone through some pretty complex theories here, which brings us to our final section, why this word matters. What's the big takeaway from this whole deep dive into one tiny word? I love this funnel analogy. It just captures the whole thing perfectly. Trying to define many with a single number is like trying to measure the big end of a funnel. The answer only makes sense if you know where you're measuring and what you're trying to do. And that's the core lesson here. Meaning isn't some fixed point.
It's a relationship between the word, the context, and the purpose.
And that's why words like many are so important. They show us that human language is incredibly flexible, it's nuanced, and it's built for a world that just isn't black and white. So when we study these problem words, what we're really seeing is the incredible sophistication of our own minds. These words aren't bugs in the system, they're features. They're designed precisely for the complex reality we live in.
And it really leaves you wondering, doesn't it? If a word as simple as many can hold this much complexity, what other amazing enigmas are just hiding in the words we use every single day, waiting to be discovered?